Hello everyone, I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Today, we are discuss about analysis and design of algorithm, and we are discuss about unit number 2, asymptotic notation. So, what is the asymptotic notation and what are the importance of the asymptotic notation and what is the complexity, how can you find particular algorithm, which complexity is best, you have saw that. So this is the important task of the asymptotic notation. So now we can start the asymptotic notation. First of all, we discuss the some of the introduction and what is the algorithm and what is the useful of the introduction. The algorithm is a finite set of precise instructions for the performing the computational or solve the following problems. So algorithm, it means you have defined the predefined some of the instruction and perform based on the instruction and solve the computational solve the problem. So this is mostly algorithm is for. What is the goal of the analysis of algorithm? To compare the algorithm mainly in terms of running time, but also in terms of the other factors. So what is the main goal of the analysis of algorithm? It means what is the instruction sort, bubble sort, and all the merge sort, and what is the importance and how can you analyze the algorithm? Mostly in the running time of complexity, but mostly another factor is require some of the memory requirement, programming impact, and many more factors you have analyzed the algorithm. Then next we can show that what do you means by running time analysis? How can you say that the algorithm is particular running time analysis? Determine how the running time will be increased, the size of the problems we can increase. So running time is increased, the more number of time, and then size of the problems is also be large. Then complexity or and all the information is related of the time is very high. So this is the importance of the analysis of algorithm. How can you solve the particular problems in the best way and running time of your algorithm is less. This is the importance of the algorithm. The input size, the number of factors which are affected in the asymptotic notation in the algorithm. Input size, it means you can say that the input size, it means the number of element in the input, how many number of element in the input particular algorithm, size of the array, what are the size of particular array in your algorithm or any input, polynomial degree, then element of the matrix or bits in the binary represent of the input and vertical and edge in the graph. So all the factors which are affected how the input in particular algorithm you have applied. What types of input in your algorithm and which algorithm you have applied and represent the complexity or notation. Next, the importance topic of the any algorithm, order of growth, how the particular sequential manage in particular order of growth. You have said that the complexity or any find the particular algorithm based on the order of growth. For example, you have the order of the, you have saw that 1, then log n, then n under root n, you have said that n log n square, n cube, n raised to 4, n raised to 6, you have continued so that then after 2 raised to n, then n factorial. So this is the order of growth. You can show that the particular way of the asymptotic notation. So this is the basic introduction and the all the important tasks of the asymptotic notation. Now we can show that how can you analyze the particular algorithm. The analysis of the particular algorithm is a three-way. First is worst case, it means it is not particular way or maximum time is required. Then best case based on the learning time and average case. So now we can discuss the types of analysis. The worst case, provide the upper bound of the running time. It means the absolute guarantee that the algorithm would not be run longer. or no matter what is the input are. It means maximum amount of time will be complete the process. So this is called the worst case. And then what is the best case? Provided the low bound of the running time. Input is the one for which is the algorithm run in the faster. It means which algorithm run faster and provide some output for the particular way of the input. So this is the best case. And then what is the average case? Provide some prediction about the running time. You can say that this is the time of the particular assumption of the input of the random sequence. This is called the average case. You can show that the assume that the input of the random. So this is the analysis of the algorithm. Three types of way of the analysis: worst case, best case, and average case. Now the topic is asymptotic notation. So what is the word of the asymptotic notation? The word of the asymptotic notation means the approaching the value of the curve of the ability closely. It means some shortest limitation we can take and process we can complete it. And asymptotic analysis. It means it is a technique for the representing the limited behavior. The methodology is the application across the science. It can be used for the analyze the performing the algorithm some large number of data sets. So this is the asymptotic notation. If you check that and then perform particular analysis for particular large number of data. Now we can start the asymptotic notation and all the information. Then asymptotic analysis also by algorithm is referred to define the mathematical boundary of its running time of performance. Using asymptotic analysis, we can very well conduct the best case, average case, and worst case scenario of the algorithm. So based on the asymptotic notation, we can find the best case, worst case, and average case based on the mathematical using. So asymptotic notation, we can also be show that it are three types: worst case, best case, and average case. So now we can start that. So what is the worst case? The maximum amount of time is required for the particular program for the execution. It is called the worst case. We can repeat that the definition. What is the worst case? The maximum amount of time is required for particular program for the execution. It is called the worst case. And the defined is a big omega notation. And the complexity of the worst case is mostly n. And then what is the best case? The minimum amount of time is required for particular program for the execution. It is called the best case. And it is defined by the omega notation. And the complexity is a 1. Then what is the average case? The average amount of time is required for execution. It means not a best case, not a worst case, but the middle of the both. And it is called the average case. The average amount of time is required for the particular execution. It is called the average case. It is defined of the theta notation, and complexity is mostly n plus 1 divided by 2. So this is the asymptotic notation. You have saw that. Now we can discuss the briefly what is the omega notation. It means what is the worst case representation, best case representation, and average case representation. So now we can start the big omega notation. It means worst case representation. So the big omega notation, it means the worst case. Big omega is g of n is denoted the function of n. There is existing positive constant of c and n0. So you have saw that here. This is the representation of the big omega. This is the n, and you have said that this is the any value of the x or any other function. This is represent of the f of n. So what is the f of n? F of n is a lower compared to f c of g of n. It means 0 is less than equal to f of n less than equal to c of g of n. You have saw that the representation of the c of g of n is a upper bound of the f of n. It means the function of f of n is a lower compared to c of g of n. Or you have said that g of n is a upper bound of f of n. This is called the worst case. So what is the worst case? G of n is a upper bound of the f of n. It is called the worst case, and it is represent of the this form. You have saw that this is the f of n function, and then this is the g of n function, and 0 is less than equal to f of n less than equal to c of g of n for all the n is greater or equal to n0. So this is the formula you have prepared, that 0 is less than equal to f of n and less than equal to c g of n. So this is the representation of the big omega notation. So the worst case is represent the upper bound. Also the complexity is n, you have saw that, and maximum amount of time is required particular algorithm. So this is the representation. The big omega notation, it is the big O. The notation of big omega is n. It is represent big O bracket of n is formally way to express the upper bound of the algorithm of the running time. You have saw that here, the upper bound of the g of n. It means the worst case of time complexity or the longest amount of time is required to algorithm can possible taken to complete the process. It means the maximum amount of time, because of g of n is a greater of the f of n. So maximum amount of time is required to complete the process of the big omega notation. So this is the longest time possibility for the take to complete the task. It is called the big omega notation. So this is the big omega notation. So now next we can show that the omega notation. So you have saw that here the c of g of n is a lower of the f of n. It means it is a lower bound of g of n. So g of n is a lower bound of the f of n. It means this is the notation is denoted by the best case. So g of n, it means there is the existing positive constant of c and n of 0. So 0 is less than equal to c g of n less than equal to f of n. So you have saw that the diagrams, the f of n is a greater of the g of n. It means it is the best way to representation of the g of n, and it is the maximum possibility to complete the time, and it is represent the best case. So what is the best case? The g of n is a lower bound for the f of n. It is the best case, and here g of n is the upper bound of the f of n. It is called the worst case. So the next we can solve that here. The equation is importance of the best case. 0 is less than equal to c of g of n less than equal to f of n. The notation of the omega is formally way to express the lower bound of the algorithm of the running time complexity. You have saw that here. G of n is a lower of the f of n. So it means the best case time complexity or the best amount of time is algorithm can be possible take to complete the time. So this is the omega notation. Next we are discuss the theta notation. It means the average case. The average case is denoted the theta of g of n or theta notation. There is the existing possible or positive constant of c of 1, c2 and n0. You have saw that here. The equation is 0 is less than equal to c1 of g of n less than equal to f of n and less than equal to c2 g of n. So what is the representation of the theta? It means it is not a best case, not a worst case. So you have saw that this is the representation of the c of g of n. It means c1 of g of n and c2 of g of n. So c1 of g of n, you have said that this is the best case, and c2 of g of n, this is the worst case. and f of n, it is representation of the average case. So here you have saw that g of n is asymptotic tightly bound for the f of n. So here the c1 and c2 is represent of the g of n, but here the c1 is the best case, c2 is the worst case, and f of n is the average case. So the equation you have saw that 0 is less than equal to c1 of g of n, less than equal to f of n, less than equal to c2 of g of n. So this is the notation of the average case. The theta notation. The notation of theta is denoted is formally this one, and both the lower bound and upper bound algorithm of the running time complexity. So you have saw that this is the lower bound, it means the best case, and upper bound for the worst case, it is represent of the theta, and the average case complexity is mostly n plus 1 divided by 2 we have discussed. So this is the importance for the asymptotic notation. We have show that in the briefly and repeat that. So this is the algorithm we can discuss, and what is the goal of the analysis. You can analysis is importance particular algorithm. It means you have calculate the particular time of the complexity of the algorithm. What is the size of input? The input size is you have said that the array based elemetrics of matrix based binary representation. So this is the input. Order of growth. How can you say that the particular algorithm or order of growth of the any function? This is the representation of the 1 log n, root of n, n log n, n square, n cube, n raised to 4, all the continue, 2 raised to n, and n factorial. This is the representation of the order of n. Types of analysis. You have said that 3 types of analysis: worst case, best case, and average case. Then you have said that what is the worst case? The maximum amount of time is required to complete the process of the execution. It is called the worst case, and it is the notation is a big omega and complexity is a n. What is the best case? Minimum amount of time is required to process to complete the execution. It is the best case, and it is denoted the omega notation, and the complexity is the 1 for the best case. And what is the average case? The average of time, it means the prediction of the time is required to program of the execution in the particular algorithm. It is the denoted by the theta notation, and complexity is n plus 1 divided by 2. So this is the notation, asymptotic notation. You have saw that the 3 types of notation: big omega. So 3 types of notation we can show that: the big omega notation, theta, and the omega notation. So big omega, you have saw that the g of n is the upper bound of the f of n. So this is the worst case for omega notation. Here, what is the best case? G of n is a lower bound of the f of n. You have saw that this is the lower bound. The function is lower bound. So this is called the lower case. And theta notation, it is the average. It means best case. This is the representation of the c1 of g of n, and c2 of g of n is the worst case, and f of n is the middle of the both. It is called the average case. So this is the asymptotic notation. So the question is, you have write the asymptotic notation, the best case, average case, worst case. Now you have find the complexity of the all the notation. So this is the information of the asymptotic notation. Thank you all of you.